Hey everyone, welcome to my channel, Bug No Jutsu. In today's video, we're going to build a stopwatch app using HTML, CSS, and JavaScript from scratch. This beginner-friendly project is perfect for anyone looking to improve their front-end development skills through hands-on learning. You'll learn how to structure the layout using HTML, style it with modern CSS, and make it fully functional with JavaScript, including start, pause, and reset features. By the end of the video, you'll have a polished, real-time stopwatch that you can showcase in your portfolio or enhance with more features. Let's dive in and start coding together. Document declaration and root structure. The first line in the file is the doc type declaration. It tells the browser that this is an HTML5 document, ensuring modern rendering behavior. Without this declaration, browsers might switch to quirks mode, which can cause inconsistent layout behavior. The HTML tag is the root element of the HTML document. The head section contains information about the document, not the content that will be displayed. Everything inside the body tag is rendered on the web page. This is where users interact with the app. Div class equal to container, a wrapper that holds all the UI elements of the stopwatch. The class container is used in CSS to apply layout styles like padding, alignment, and background effects. H1, heading, displays the main title of the page, Stopwatch. The H1 tag represents the most important heading and is useful for SEO and accessibility. Semantic HTML helps search engines and screen readers interpret content structure properly. Div, ID equal to display, class equal to time. This div is responsible for showing the current time, initially set to 00 period. The ID equal to display is used in JavaScript to dynamically update the content inside this div in real time. The class equal to time is used in CSS to style the font size, alignment, and appearance of the displayed time. Div class equal to buttons acts as a container for all three control buttons. Using a separate container makes it easier to style the buttons together using CSS Flexbox or Grid. Button ID equal to start button, a clickable button element that triggers the start of the stopwatch. The ID equal to start button is used in JavaScript to add an event listener that starts the timer. Buttons are semantic and accessible elements that are keyboard friendly and screen reader compatible. Button tag ID equal to pause button, content equal to pause. Similar to the start button, this one is used to pause the timer. The ID equal to pause button allows JavaScript to find and attach a click handler that stops updating the time temporarily. Button tag ID equal to reset button and content equal to reset. This button resets the stopwatch back to 0. The ID equal to reset button lets the script access this element to define the reset functionality. HTML, hypertext markup language, is the foundation of every website and web application. It provides the structure and layout for your content. Everything from headings and paragraphs to buttons and containers starts with HTML. Why HTML is important? It's the skeleton of the web, allowing developers to organize and display content meaningfully. Enables semantic structure, making websites accessible to all users, including screen readers and search engines. Forms the base on which CSS, styling, and JavaScript functionality operate. It's easy to learn, making it the perfect starting point for new developers. Whether you're building a simple project like a stopwatch or a complex web app, HTML is always the first step. Without it, nothing else works. That's why it's an essential skill for every front-end developer. Font family, Sogol UI sans serif, sets the default font for all text in the page to Sogol UI, which is a modern, clean, and readable system font. If Sogol UI is not available on the user's system, it will fall back to a generic sans serif font, which keeps the text looking clean and professional. Display Flex enables Flexbox on the body element, which turns it into a Flex container. This allows for powerful alignment capabilities of the child content, typically your main container. It helps in centering the content both vertically and horizontally when combined with the next two properties. Justify content. Center. This horizontally centers the content inside the body. Any direct child element, like your stopwatch container, will be aligned to the center along the main axis, horizontal. Align items. Center. This vertically centers the content within the body, sets the body height to 100% of the viewport height. Applies a linear gradient background that blends from a dark blue to a lighter blue. The direction to right means the gradient flows horizontally from left to right. This gives the app a visually appealing, modern background without needing images. Great for performance and design. Removes the default browser margin around the body. Sets the default text color to white. A fully centered, clean layout. The H1 tag represents the main heading of the web page, typically used for titles or key labels. In this Stopwatch app, it displays the text Stopwatch in a prominent way at the top. To make this heading stand out, the font size is set to 2.5 times the root font size using the rem unit. This ensures that the text is large and clearly visible on all screen sizes. Using rem instead of fixed units like pixels allows the design to remain accessible and scalable, adapting to different user preferences and device settings. Additionally, a margin is applied below the heading to create vertical spacing between it and the timer display. This separation enhances readability and gives the layout a clean, well-structured appearance. The .time class is applied to the element that shows the actual stopwatch time, typically in the format of minutes, seconds, and milliseconds. To draw attention and provide a digital clock-like appearance, the text is styled with a larger font size than the heading. Specifically, is set to 3 times the root font size using the rem unit, making it bold, prominent, and easy to read even from a distance. A margin is also added below this element to provide spacing between the timer and the control buttons. This visual buffer ensures that the page doesn't look cluttered and maintains a user-friendly layout. 1 rem equals to 16 pixels. The button on this Stopwatch app is styled to be visually appealing, user-friendly, and consistent with modern UI design trends. First, the background color is set to a fresh, vibrant green shade, giving the button a positive and energetic look that encourages interaction. The text color inside the button is white, ensuring a high contrast against the green background, which makes the label easy to read. To maintain a clean and minimal aesthetic, the default border is removed, resulting in a smooth edge with no visible outline. The button also has internal spacing defined through padding, both vertically and horizontally, so the text inside the button doesn't appear cramped. This padding gives the button a balanced, comfortable shape. Next, horizontal margins are applied on both sides of the button to ensure there is consistent spacing between multiple buttons. The corners of the button are rounded with a medium border radius, which gives it a soft, friendly, and modern appearance. This slight rounding avoids the harshness of sharp corners and aligns with common design standards found in apps and websites today. The font size used in the button is based on a scalable unit, rem, which ensures the text remains accessible and adjusts appropriately across devices and user settings. The pointer changes to a hand icon when hovered over, signaling to the user that the button is clickable, a small but essential detail for good user experience. Finally, a transition effect is applied to the background color, making any changes, like hover effects, appear smooth and polished rather than abrupt. This contributes to a more professional and satisfying interactive experience. When a user hovers their cursor over the button, a darker shade of green replaces the original background color. This darker green provides clear feedback that the button is being interacted with, improving the overall usability. Since a transition is already in place, the color change occurs gradually, enhancing the visual quality of the interaction. This hover effect not only gives users immediate feedback, but also makes the interface feel more dynamic and responsive. It's an important part of modern web design, as it helps users understand which elements are interactive and improves engagement by making actions feel intuitive. Once you define styles in CSS, you can reuse them across your website. Change one style in your style sheet, and it updates everywhere, saving time and reducing errors. This is especially powerful with tools like classes, variables, and frameworks. Efficient CSS helps your pages load faster. Instead of using large images or JavaScript for visual styling, CSS can handle complex layouts and visual effects, like transitions, animations, and shadows without heavy resources. With proper CSS, you can ensure a consistent experience for all users, including those using screen readers or customized browser settings. Consistent font sizes, contrast, and focus indicators make your site more inclusive and professional. Let's start time, difference, time interval. Here, we are declaring 3 variables using let, which means their values can change later. Start timestamp. This will hold the exact time in milliseconds when the stopwatch was started. It uses the current system time through JavaScript's date.getTime method. Difference. This keeps track of how much time has passed between starting and pausing the stopwatch. It allows the stopwatch to resume from where it left off instead of resetting every time. Time interval. This will store the interval ID from the setInterval function, which is used to repeatedly call a function to update the time display every few milliseconds. Having this stored allows you to pause or stop the timer later using clear interval. Let is running equal to false. This is a Boolean flag used to track whether the stopwatch is currently running or not. If it's true, the timer is active and ticking. If it's false, the stopwatch is either paused or hasn't been started yet. This helps prevent bugs like starting the stopwatch multiple times or resuming it unnecessarily. Const display equal to document.getElement by ID of display. This line connects the timer display area from your HTML to JavaScript. Whatever changes you make to display.text content in JS will directly reflect on the web page where the timer is shown, like 00:00:00. These 3 lines are connecting your start, pause, and reset buttons from HTML to JavaScript using their respective IDs. Once connected, you can use JavaScript to listen for clicks on each button and define what should happen, such as starting, stopping, or resetting the timer. This part of the code defines what happens when a user clicks the Start button on your stopwatch. When the Start button is clicked, JavaScript first checks if the stopwatch is currently not running. This check is important. It prevents multiple intervals from being triggered if the user clicks the Start button repeatedly. We only want one timer running at a time. Once it confirms that the stopwatch isn't already active, it flips the state to indicate that the stopwatch is now running. Then comes the most important step. It captures the current system time as the starting point. But there's a smart detail here. If the stopwatch was previously paused, it doesn't start from 0 again. Instead, it subtracts the already recorded elapsed time so that the stopwatch resumes from where it left off, not restarts. This is how the resume functionality works seamlessly. Finally, the code sets up a repeating timer using JavaScript's interval mechanism. This means a specific function, the one responsible for updating the timer display, is scheduled to run repeatedly, every few milliseconds, so the stopwatch time continues to update live on the screen. When the user clicks the pause button, this section of the code checks if the stopwatch is currently running. This check is necessary to ensure that the pause action only takes place if the stopwatch is active. Once confirmed, it changes the state to indicate that the stopwatch is no longer running. This effectively tells the rest of the program to stop updating the timer. Next, the repeating update mechanism, which was actively refreshing the time display, is cleared. This stops the ongoing process that was responsible for counting and showing time in real time. Finally, it records how much time has passed up to that point by subtracting the original start time from the current system time. This value is stored so that if the user decides to press start again, the stopwatch can resume from where it left off instead of starting over. When the reset button is clicked by the user, the code executes a series of actions to completely stop and reset the stopwatch, returning it to its initial state. The first thing it does is change the running state to false, which informs the entire program that the stopwatch is no longer active. This ensures that no further time calculations or updates are attempted. Next, it stops the ongoing timer interval. Remember, the stopwatch works by continuously calling a function every few milliseconds to update the display. Resetting needs to cancel that repeating action, so the interval is cleared. This prevents the stopwatch from continuing to count time in the background. After stopping the timer, the stopwatch display is visually reset. The numbers shown on the screen, usually formatted as minutes, seconds, and milliseconds, are cleared and replaced with the original starting value, typically 0000. This gives the user a clear visual cue that the stopwatch is now at 0 and ready to start again. Finally, it resets the recorded time difference to 0. This is very important because it ensures that when the user starts the stopwatch again, it doesn't resume from a previous value. It begins counting time fresh from 0. Creating a stopwatch using HTML, CSS, and JavaScript may seem like a basic task, but it's actually a powerful way to understand how core web technologies work together. HTML gives structure to your application, from the buttons to the timer display, teaching you how to properly organize and label UI elements for both users and developers. It's the foundation where all content lives and sets the stage for interactivity. CSS takes that basic structure and transforms it into something visually appealing. You use styles to center content, add gradients for depth, design attractive buttons, and create hover effects that make the stopwatch feel modern and responsive. Through this, you learn how design and user experience play a huge role in whether users enjoy using your app or not. JavaScript brings life to the project by enabling real-time interactivity. It handles the stopwatch logic, keeping track of time, starting and stopping intervals, calculating elapsed time, and updating the display dynamically. You also work with user events and browser APIs like date and set interval, which teaches you how JavaScript communicates with both time and the DOM to update your interface. Overall, this project teaches essential coding concepts: UI structuring, design responsiveness, time logic, user event handling, and basic state management. It's an ideal beginner to intermediate project because it's practical, real-time, and expandable. Once you complete it, you gain the confidence to tackle more advanced applications while understanding the flow of a complete front-end build. This update time function is the heartbeat of the stopwatch. It's responsible for continuously calculating how much time has passed since the stopwatch started, breaking that time down into minutes, seconds, and milliseconds, and then updating the screen to show that live, ticking value. Let's explore what it does step by step. Capturing the current time. The function begins by retrieving the current system time, essentially the exact moment when this function runs. In a stopwatch, this step is necessary to measure how far we've come from the initial start moment. 2. Calculating time elapsed. Next, it calculates the difference between the current time and the moment the stopwatch was started. This gives us the total amount of time that has passed since the user hit the Start button, measured in milliseconds. This time difference is what the stopwatch needs to show on the screen. Breaking time into units: minutes, seconds, milliseconds. Now that we have the total time in milliseconds, the function converts that number into readable components. Minutes. It calculates how many full minutes have passed. This is done by dividing the total milliseconds by 60,000, because 1 minute equals 60,000 milliseconds. Seconds. Then, it figures out how many seconds remain after the full minutes are removed. This is done by calculating the remainder after dividing by 60,000, and then converting that to seconds. Milliseconds. Finally, it calculates how many milliseconds remain after removing both full minutes and seconds. Since the display only shows 2-digit milliseconds, hundredths of a second, it divides the remainder by 10, as 1 second equals 1,000 milliseconds, and we want 2 decimal digits. This breakdown ensures the stopwatch shows time in the format MMSSMS. With all the time values calculated, the function then updates the stopwatch screen by setting the visible text to the newly calculated minute, second, and millisecond values. To make the display clean and consistent, e.g., 01 at 03 second 9 instead of 1 minutes at 3 seconds. It calls another function that ensures each number is padded with a 0 if it's less than 10, so all units are shown in 2 digits. This gives the timer a professional and easy-to-read look, mimicking the format of digital stopwatches or timers you'd see in real devices. This function doesn't run just once. It's triggered every 10 milliseconds by the stopwatch's internal timer loop. That means the display is refreshed 100 times per second, giving a super smooth, real-time countdown feel. The pad function is a small but essential helper that ensures all the time values in your stopwatch, months, seconds, milliseconds, appear in two-digit format on the screen. When you're displaying time, numbers like 1, 5, or 9 look inconsistent compared to 01, 05, or 09. To maintain a professional, uniform appearance, just like a digital stopwatch, every unit should always be 2 digits. This function checks if the given number, called unit, is less than 10. If yes, it adds a 0 in front of it, so 5 becomes 05. If no, it just returns the number as is, so 12 remains 12. This padding ensures that even single-digit numbers are visually aligned with the rest, giving your stopwatch a clean, readable display. And that wraps up today's stopwatch project. I hope you not only learned how to build it, but also understood why each part works the way it does. If you found this helpful, make sure to like the video, subscribe to the channel, Bug No Jutsu, and hit the notification bell so you don't miss the next coding adventure. I've got a lot more exciting projects coming up, from anime-inspired web apps to gaming UI builds and more creative code breakdowns. Until then, keep coding, stay curious, and unleash your inner ninja developer. Thanks for watching. See you in the next one.